Hi, today I bring up an interesting equation about which I want to discuss, and that is an equation in kinematics which is popularly written as v square minus u square is 2as. Actually, this equation, the correct form of this equation, though most of the people write this, most of the people write this, the correct form of the equation is v square minus u square is 2a dot s. That's the correct form of the equation. It's a very strange equation. In fact, when you talk about the constant acceleration motion, we generally tend to write the following equations. One is v equal to u plus at, which you got by the basic definition, by integrating the basic definitions. And the other, of course, again, further integration gives you s equal to ut plus half at square. All these equations are to be derived very properly using calculus. And using these two, I can get two more very strange equations which you might have not seen, at least some of you. S equal to v plus u by 2 into t. You can get this third equation. Again, it is valid for constant acceleration. How did I get this? Basically, if I call these equations 1 and 2, which I got by integrating basic definitions, if you eliminate acceleration from 1 and 2, you end up with this equation 3. You eliminate acceleration from 1 and 2 and you end up with equation 3. Similarly, if you eliminate u from 1 and 2, you will end up with s equal to vt minus half at square. Most of the students don't know about this equation, vt minus half at square. Also a very interesting equation. So totally there are 5 equations in constant accelerated motion, which is one is v equal to u plus at. So I have written here all the 5 equations. 1, 2, 3, I will call this 4. And this is the 5th equation. Now 1, 2, 3, 4 are actually vector equations. The idea with vector equations is you can split them into x component and write, for example, vx is ux plus axt, and you can take the y component of the vector equation. So one vector equation is equal to 3 scalar equations along x, y, z directions. So it's like that. But this 5th equation, which I am looking at here, this is not a vector equation, rather this is a scalar equation. You cannot split this into components, at least from here you can't do that. From here at least you can't, because it's a scalar equation. This is a scalar dot product. This is v dot v, actually v square. This is u dot u square. And scalars, there is no way you can split them. So at least from here you can't write vx square minus ux square is 2ax sx. You can write this in another way by deriving it in a different way, but not from here, at least directly. Now, why is this important? So let's look at this. First of all, how did we get this equation? I'll take v equal to u plus at. I will again write v equal to u plus at and dot the equation with itself, so that you get v dot v is u plus at dot u plus at, and you get that as v square is u square plus 2u dot at plus a dot a t square. I just simplified a bit, which I can write as u square plus 2a dot ut plus half at square, and this is s. So you get v square minus u square is 2a dot s. Very important to understand a dot s. Most people say it is as. Well, in 1D motion you could say that, but a better way of writing it is always to a dot s. And actually this equation goes all the way to work energy topic. It has some relation with work energy. In fact, if I multiply with half m here, Of course, this equation we derived for constant acceleration, which means constant force. You get the work energy theorem. Ma will be force, F dot S will be work done by constant force, and the other side will have change in kinetic energy. But the point is, this is a scalar equation. So it's not v square minus u square is 2as, but rather 2a dot s. Now, what is the difference? Why I am stressing on 2a dot s? You see, suppose there is a tower of certain height, let us say 8 meters, or a wall I should say rather than a tower, and a ball is thrown horizontally with, let us say, 4 meters per second, and there is acceleration due to gravity 10. Suppose I want to find the speed of the ball by the time it comes here. Of course, it's going in a parabolic path. I am assuming g is constant. So the displacement of the ball is actually this line segment, and a or g is in this direction. So if I can directly apply v square minus u square is 2a dot s here, because even though it's a projectile motion, it's under constant acceleration. And if this angle between a and s is theta, I can write as 2, magnitude of a is g, magnitude of s is s into cos theta, and luckily s cos theta is already height of the tower, which is 2g into 8. So you see, ultimately the speed depends only on the height. Some people write like this: v square minus u square is 2g into 8. They are taking the acceleration in vertical direction, displacement in vertical direction. How? What is the proof? The proof is coming from here. If you use 2a dot s, you get the correct proof. Or you can even split the motion into horizontal and vertical separately and do it. But my point of stressing on this is, whenever you use the equation v square minus u square equal to 2, don't say as, rather use a dot s and do the proper dot product between a and s and solve the problem. It will avoid all the confusion. So that is what I wanted to tell in this video. Thank you.